In this video, we will talk about the properties of solids, liquids, and gases based on the particle nature of matter. So let's get started. When you compare the pencil, laptop, and smartphone, surely you will say that the laptop is the heaviest of the three objects, while the pencil seems to be the lightest. On the other hand, the smartphone may not be as heavy as the laptop, but it is not as light as the pencil. What does this indicate? It means that objects or things around us may be light or heavy, or, simply put, that these things have mass. Mass is the measure of the amount of matter the object has. The objects in the picture show that they occupy a space. Volume is the measure of the space occupied by an object. So what do we call these objects that have mass and volume? We call them matter. How about air inside a balloon? Does it have mass? Does it occupy space? The air placed inside the balloon occupies space. Thus, we are able to inflate balloons. Air also adds mass to balloons. Hence, the air inside balloons are considered as matter. How about heat and light? Do they have mass? Do they occupy space? Heat is energy in transit, and light is a form of energy. They do not have mass and they do not occupy space, so they are not considered matter. Variety in matter can be traced to the nature of the particles composing them. One example of matter noted for its variety in physical form is water. Water is a common substance that we encounter every day. The icebergs, the ocean water, and the vapor in the sky are all considered water, but they are of different states. Alright, let's do a quick activity. Fill a cylindrical glass bottle with water up to the 10 ml mark. The bottle has line markings for the 10 ml and the 16 ml mark. The lower line marking is the 10 ml mark, while the higher one is the 16 ml mark. Add 5 1/4 teaspoonfuls of sugar in the bottle. Mix or shake thoroughly until all the sugar is dissolved. What is the volume of the sugar and water mixture? What should be the total volume of the solution? Now let's recall the volumes in our experiment. We poured 10 ml of water in the cylindrical glass bottle. We added 1/4 teaspoon of sugar to the cylindrical glass bottle 5 times. Note that 1/4 teaspoon is equivalent to 1.2 ml. Therefore, 1.2 ml times 5 equals 6 ml of sugar. So the total volume inside the cylindrical glass bottle must be 10 ml of water plus 6 ml of sugar equals 16 ml. You have observed that the resulting volume is less than 16 ml. Why is this so? Water is made up of tiny particles called molecules with spaces between them. Sugar is also made up of molecules bigger than the molecules of water. The water molecules could fit in the spaces between the sugar molecules, or vice versa. Let's continue with another activity. Pour 1 cup of tap water into a transparent glass bottle. Add 1 small drop of food coloring slowly. You may have observed that the food coloring starts to spread to the other parts of the water. Set aside the bottle with food coloring in a locker or corner of your room without disturbing the setup. After 1 day, what happens to the food coloring dropped in the bottle containing water? Think about food coloring and water as made up of particles. You may have observed this time that the food coloring is evenly scattered all throughout the water.